Alright, this is going to be a fun page about drug actions. So for this, you just need a blank piece of computer paper like I have, and then write drug actions across the top. You're going to draw your own pictures on this page. So let's imagine that you have an axon terminal right here, and a postsynaptic receptor right here. And think of some different ways that effects could occur. And go ahead and make the receptors orange like on the last page. And the pink synaptic vesicles, or the fat sacs, that contain neurotransmitters. And we're also going to add another structure called a reuptake pump. Maybe make that yellow. And then put a channel here. Maybe make that blue. We'll call that a postsynaptic membrane channel. Okay, so let's imagine some different ways that a drug could work. First of all, what if you made a blocker of the receptor? So let's just use our black pen for this. And what if you blocked the effect? Block the receptor. One of the ways that this can happen is with, as we mentioned, a beta blocker. There's also cholinergic blockers that can be given, either as muscle relaxants or to keep the heart going fast enough, like atropine. So atropine is an example of that. Okay, so you tried blocking the receptor. What about a drug that might block the channel? So normally when a neurotransmitter binds to the receptor, then a channel opens on the postsynaptic membrane. And what if you just block that channel? And sure enough, for some forms of heart problems, calcium channel blockers are given. And then after, so what that would do then is decrease heart rate, basically, and contractility if this were blocked. So that's two effects. Now, the next thing you might think about is what normally happens is that the neurotransmitters get degraded. To put this as number 3, what if you blocked the degradation of the neurotransmitters so that they stay on there longer? One of the ways that antidepressants work is, for example, with selective serotonin reuptake inhibitors. Or SSRIs. And those can then block either the degradation or the next part over here, the reuptake. So we'll put this as a fourth possibility. what if you were to block the action of that? Block reuptake. And for example, this is how cocaine works. Cocaine blocks reuptake of dopamine. So what you end up with is more dopamine in the synaptic cleft, so it has a longer effect on the postsynaptic membrane. And dopamine is a feel-good transmitter or neurotransmitter, so that's why cocaine makes you feel good. Similarly, you could have what if the drug allowed more of the neurotransmitter to come out? So we could put that as a fifth option. Stimulate the neurotransmitter release, and that's what methamphetamine does this with dopamine. So methamphetamine and cocaine both have their effect by either stimulating dopamine release or blocking the reuptake of dopamine, and essentially then it causes more dopamine to be binding to the receptor. Serotonin reuptake inhibitors block the degradation of serotonin, and in doing so, then they're able to keep the serotonin having its mood regulating effect on the postsynaptic membrane for longer. Calcium channel blockers block the entry of calcium into the cardiac muscle cell, and because they're blocking that, then the calcium is not having its normal excitatory effect on cardiac muscle cells, so it's going to have the heart go slower. Or a beta blocker could also make the heart go slower by blocking the binding of norepinephrine. Maybe we should add that. So it blocks norepinephrine from binding. Cholinergic blockers like atropine, they block acetylcholine from binding to a cardiac cell. And so if someone's heart needs like a whoa, you got to get moving, you could give the patient atropine. If the patient's heart needs to slow down or rest, then they could be given a beta blocker.